out, and it takes a little while before searching updates to, oh, there's nothing in it, so it's not going to. Before it updates to, don't make a liar out of me searching. I think it has a minimum length too. It does. Before searching updates to another, before it does another search. So if I'm searching for Indian elephants now, and I stop for a second, it does a search. But then while I'm typing, it's not searching, and now it does. So a very efficient way of searching, of using an API where whenever you do a call, you incur some cost, and so you don't want to do that call unless you need to. And this is kind of built right in. How do you do that delay? Well, you can imagine how you would do that delay on your own, but in here, the way that you do that delay is with a debounce. Debounce for 750 milliseconds, and then do a distinctive change. So in other words, if I didn't change anything about my search box, don't do another search. I just gave you the results for that. And so one-line operators like that end up doing a lot of state management and cleanup for you, and they make your life easier. Now the next couple I'm just going to show you so that you can go look up the implementation on your own. One of them is called drag and drop. Pretty interesting that you can implement drag and drop. Again, this is handling mouse down, mouse up, mouse move, all of that, and allowing me to drag an object around. Of course, browsers have built-in drag and drop capability now, but it's not using that. It's actually doing it manually and just moving the position of that. And then the last one that I wanted to show you is called alphabet invasion. And alphabet invasion is a complete game written pretty much entirely in Reactive Extensions. So press any key to start, the letters fall down. This is level 1. There's a G, E. Oh, you know what? I remember I found the bug in the code even. Certain keys don't work because the browser overwrites and captures that key for me, and so it doesn't send it to the game, so that's a bug since that was created. But let's look at the implementation of that one. That one's pretty huge and pretty interesting. I'm going to zoom out so you get a sense of the size of this one. How far out will code zoom? Here we go. That's it. So there's. Okay, so it's about 3 screens at that size, so you can get a feeling for what size it is. But you can see that they made all of the levels, and then they basically just implemented the whole thing in Reactive Extensions. And so I like this example because it can convince you that you can make larger scale things using Reactive Extensions in a lot of places. It's one of those things like Link where once you kind of wrap your head around it, you're like, oh man, places I could use that. And in this case, they may have gone overboard and they just used it for the entire game. So that's that, and now a few resources for you. Like I said, it is kind of split into 2 pieces. These are the 2 best ways to learn Reactive Extensions in my opinion. And then go back to version 4 if you want to work with version 4. There it is on GitHub, and there's those examples we were just looking at. Version 5, the main website for that is reactivex.io. Really good resources at reactivex.io. The way that the documentation is organized is you go find a operator like the flat map operator, and then it shows you that the various languages that Reactive Extension is implemented in, and you can jump into the specific ones. So for C#, of course, it's called select, or it's called select many, and it shows you how to use that. But then you can jump over to the RxJS version, which is going to be called flat map, and it shows you how to use that. So really good website there. There's the repo and a bunch of tutorials on it. So I personally used Reactive Extensions for an open source project that I created. If you go to my GitHub account, to Code Foster Water Rower. Water Rower is an application that allows you to, it's a node module that allows you to talk to a water rower. I don't know if you guys have heard of the water rower exercise machine, but it basically has a little sender unit on it with a USB port. You can just plug it into your computer and access the data that's being generated as you work out over USB. And so I wrote a node module that uses it. And it uses the typical, if you're familiar with Node, you'll recognize this pattern, waterrower.onData. It uses the event emitter pattern. But I also implemented it using reactive extensions, so you can say waterrower.dataPoints subscribe. And that way you can do things like, you can say for all the reads, filter them down, I'm only interested in this kind, and then subscribe. So you can use it as reactive extensions in the reactive extensions way very easily. So I made that, and then the next thing that I'm working on, I actually brought this here. I found out that, so I'm a boater. My wife and I recently bought this. So boats generate a lot of data, wind data, engine data, all kinds of stuff. And I found a guy at Microsoft that worked on this project and with a company called Digital Yacht, and they make these little boxes. And with this little box, I can plug this into the NMEA network inside my boat, and it will generate a web service with JSON results and even a WebSocket endpoint for all the data that's generated from my boat. And so the plan is to use reactive extensions, and for things like this, it's just absolutely ideal because you have a stream of data with various characteristics, and if you get it as a RX stream, then it makes it really easy to manipulate it, compose it, and all kinds of things. So,
are you going to automate your Excel?
I'm not going to, actually to some degree, because it does have an autopilot, so I can send messages back to the network myself and tell it, steer to the right 5 degrees or something, but I'm not there yet. I read a story online of a guy with a remote control up on the bow of the boat, just click and steer right 5 degrees, steer left 5 degrees. Everybody else on the water thinks it's wizardry. Is that you?
I've done that.
You've done that. Of course you have.
Can't you just enjoy it?
Can't you just sail? Can't you just sail? Any other questions? Yeah.
Yes, can you explain again? At the very beginning you said that the observer is synchronous in nature?
The observable?
Yeah, the observable is synchronous.
It can kind of be either. I mean, if you just generate an observable from a scalar or a vector object, it's going to return it. It's going to return it as quickly as it can. It's like a function returns a result as quickly as it can. And in that sense, it's synchronous. But if something happens within that is that has timing built in, for instance, if it's check a row from the database, and database calls are relatively expensive, and so it takes a second between each one, then you actually have control in between each row that is kicked or returned from that. So since you have control, it is asynchronous.
But only if you use like basic await.
You don't have to use async await with it because you're essentially, when you do the subscribe, whether you're using .NET or JavaScript, you're saying, here's what I want to happen whenever a row is read. And now you can go about doing other things or not. It doesn't matter, but your code runs whenever a row is read.
Is there like threads everywhere to make all this happen?
No. Now you can use threads with reactive extensions.
But is it using threads behind? I mean, how is it?
I don't remember what. So there's a layer of reactive extensions that is, I forgot the name for it. There's the scheduler, and then there's a piece that coordinates the concurrency like that. And I don't remember the default mode in C# the way in .NET the way that it's written, but you can change it and control it. And I think that by default it uses the thread pool, but I don't remember. Yeah, I don't remember. And you have control over it. Yeah.
So for the if the subscribing code is taking like too long, will that impede the next week or the next sequence in the observable?
I don't know what happens in that case. Whenever I'm on a single thread, I assume we're on a single thread, right? Because if I'm on a multiple thread, then it's obviously just going to be adding it to the pool, and another thread's going to be handling it. But if I'm handling it single-threaded and I'm still working on running a subscription function, and there's another one that lands, I think it's just going to be queued up and the timing is going to be off because my timing is bad. I mean, I'm not able to keep up. I think. I'm not sure. I'm speculating.
Is there a timeout operator too? I haven't seen that.
It rings a bell. I don't remember. I haven't used it. Yeah.
So if I create some loop, So that event will trigger the same event again and again. Will it detect it?
Will it detect that loop?
Yeah, like, are there any features like to avoid obvious issues like that?
Not that I know of. What you're talking about is causing a kick. Like what I showed you was some built-in observable functions that are like factory functions that create observables, and some conversion functions that take existing things like arrays and DOM events and turn them into observables. But you can easily create for yourself an observable and define when it kicks. So you could manually go convert some other pattern into an observable by just saying, I want an observable, and I want to do this loop, and every time this loop resolves, I want to wait 2 seconds and then kick, and then kick, and then kick. And essentially what you're doing is you're just calling the next function of that observable, so that every subscriber will then get a
Does
kick.
mean can I avoid it somehow?
Yeah, I don't know about that. It doesn't seem like that would be the job of the observable framework, in my opinion. Because at that point, you're in control of defining, implementing an observable, so maybe you're in control of, you know. Yeah?
Whenever you had that 4-quadrant rectangle and you were trying to figure out the northeast corner.
And I got it right, didn't I? I'm a sailor, I hope so.
Observable. Could you also say, this is like mathematics, that northeast quadrant quarter is equal to 1/3 array, 1/3 t plus 1/3 t plus 1/3 type t. And the quarter now can be replaced by observable. And can take on the parameters of the array, t, type t.
Wow. So you're saying that observable, there's a formula in your head, observable equals t divided by 3 plus array of type t divided by 3 plus, that's amazing.
Because each quadrant is a third of the total.
Yeah?
Third array,
Well, it's a
third
fourth.
t, and a third type t. And that's equal to a quarter or observable.
It's a fourth, isn't it? Yeah, it's a fourth. But you're saying it could be this plus this plus this?
A third array, a third t plus a third half t equal to quarter or a quarter.
You're in a higher dimension than I am. But I want to see the results. Sounds very intriguing. Any other questions? Yeah.
How does this compare to like the actor pattern? Akka.net.
Can somebody else answer that? I don't know the actor pattern well enough. I think that's an interesting parallel to draw, but I feel like I would have to have a deeper understanding of the actor pattern. Chris, can you answer that? No? Yeah, sorry. Yeah.
This reminds me of reactive programming in Akka, which uses message passing and the actor pattern.
Yeah. Scala, Ada.
Are observables threads like that for? And also, like, what does the debugging unit testing experience look like?
So the debugging is going to be pretty good in .NET. But I haven't used RX extensively in .NET, so all I know is that it's good because I remember a .NET presentation on Reactive Extensions, and they were stepping through, and it was all very good. As to inherent type safety, I don't think it's inherently type safe. If you opt for an underlying structure that uses threads, then I think you're responsible for making sure that you're not, for instance, updating an array or something from inside your subscription function, because it wouldn't be type safe. I don't think there's anything built in. I hope that's the correct answer. Yeah, that's a good question. Yeah.
Could this be the observer and hacker? It reminds me of MQTT broker.
Yeah, right.
Use publish and subscribe.
subscribe.
Yeah, they sure do. Yep. And there's all kinds of places where if you like the use of all of these operators, you can basically just take the stream of another kind and generate. I've been showing you observables, but you can create a subject. A subject is kind of like an observable, but that you also can control, that you can also tell it when to kick. So it's kind of like both. And so you create a subject, and then you can kick that subject every time, for instance, you receive an MQTT message. And now what you have is a Reactive Extensions observable, and you can use all your operators on it. So it's very common for people to do that.
MQTT broker is used a lot in IoT.
Right, right. Yeah, and this water rower that I showed you is kind of an IoT thing, and my sailboat idea is kind of an IoT thing. I'm going to have a lot of messages flying all over the place, and I would love to be able to handle those messages using Stream Library. I don't have something elegant to show right now. Yeah?
What about exceptions? How
Oh.
it works with exceptions?
I'm really glad that you brought that up. The question is, how does it work with exceptions? One of the problems with some of the other, like the promises in JavaScript and such, is that it's with observables, it's very easy to handle exceptions. Every observable has, when it throws an exception, you can handle that. Remember I showed you that exceptions either die gracefully or they die exceptionally. And so either they just end because the author decided that it's done and now this observable is done with, or an exception has been thrown and so the exception handler is fired. And so when you handle one, in most of the simplistic cases that you saw me do, I was only handling the next case. In other words, here's the function to call whenever there's a kick. But I didn't add one more function which said, this is what to do if there are any exceptions inside of this observable, that observable will die exceptionally and you'll get a chance to do something, even if that something is to restart the observable. So it's very good at handling exceptions. Okay, let's go ahead and wrap. Remember that you can download those slides on that URL. Thank you guys.